Hello dear students, in today's video we are going to discuss about the chapter metals and non-metals. In the beginning session we have already discussed certain physical properties of metals. So today we are going to discuss briefly about all the physical properties of metals and non-metals. So we already came to discuss in the previous lesson that materials that can be classified generally into metals and non-metals based on their physical properties as well as chemical properties. So in today's video we are going to look at certain physical properties of matter, especially materials such as metals and non-metals. So let us look at the first one. Say malleability. What do you mean by malleability? The ability with which an object can be broken down into thin sheets or can be beaten down into thin sheets. That is called malleability. Metals show this particular property. So they are malleable. And similarly, they can be drawn into thin wires, so which makes them ductile. So that property that is exhibited by metals and non-metals, they does not exhibit this particular, they do not exhibit this particular property. And similarly, next one is sonorous. So what do you mean by sonorous? So if you can hear one sound when you beat metals. Suppose what will happen? It will produce ringing sound. You can see similarly, you can hear one ringing sound. Is it that particular property? The ability to make ringing sound, that is called metals. If you beat two metals together, it will produce a ringing sound. So metals normally shows this particular property, but non-metals do not. Similarly, you can see here conductivity. Conductivity means what? If your frying pan is kept on the stove for a long time, after all, when you go and catch it, what will happen? Your hand will get burnt. So similarly, so with that activity, what we can understand that metals are good conductors of heat. And similarly, you can see in your textbook, it is one experiment is described, activity is described. So if you connect a metallic conductor or metallic wire or an iron nail between the two ends of a wire and the wire which is connected to a battery and a cell, or if it is connected to a bulb, so as you switch on, the bulb will start to glowing. Similarly, you can see that means the metals, especially, they conduct electricity. So they are good conductors of heat as well as electricity. So metals shows this particular property, but non-metals do not. One exception is there, graphite. It is a non-metal. It's an allotrope of carbon that also uh, somewhat conduct. Similarly, you can see next property is hardness. So metals definitely you can see. So when you look at iron nail, so it's very hard. It is so hard. And similarly, you can see aluminium. Aluminium is somewhat hard. And similarly, if you look at many of the metals, majority of the metals, they are hard. There's, but non-metals. What about non-metals? Sulfur, coal, etc. Carbons, form of carbon, they are somewhat, they're not that strong. Similarly, you can see. So non-metals do not show any particular these properties. The next one is lustrous. We already seen that. What is mean by lustrous? You can see. So silver articles. Silver articles just look like this. There will be shiny yellow color. Or gold articles. You can see. So similarly, magnesium also appears shiny. If you surface, if we clean the surface of magnesium, so it will be appearing shiny. So that particular property is known as lustrous. So these are all the general properties, general physical properties of metals. Physical properties we already discussed. Today we are going to discuss some of the chemical properties of metals and non-metals. First we will start with the metals, the chemical properties of metals. So in the previous classes we already discussed that. What do you mean by chemical property? The chemical property of a substance or a particular material. These are the properties that are associated with its real nature. So we can identify. Suppose if you burn a piece of paper, so what will happen? It will turn to ash. Similarly, if you keep an iron nail, say suppose if you keep an iron nail for a very long time exposed to atmosphere, what will happen? its surface will get coated with uh, some brownish color substance. So that is known as rust. So the first physical property. So we discussed about the physical properties only. So that means which does not affect the nature of that particular material. But here in this lesson, we are going to discuss about the chemical properties. Suppose if you keep milk for a long time, for over a day, what will happen? It will turn to curd. Will the milk and curd taste the same? Are they similar? Are they same? No. So they are different. Uh, they have got different properties. So similarly, you can see one substance is getting changed to another substance. So this is what happening during a chemical change. So in the physical change, you may already know that physical change, what is happening? Only phase transition. That means states are getting converted from solid to liquid, liquid to gas, or gas back to liquid, and liquid back to solid, or solid directly to gas. So these are some of the physical properties, and also we discuss about malleability, ductility, these all. So Naras conductor, whether it is a good conductor or not, then lustrous or hard density. These are the physical properties of matter, especially metals and non-metals. So today we are going to discuss about what happened to iron when it is exposed to moisture over a long period of time. So we can see. So here I have written symbol of iron, symbol of the metal iron, Fe, capital letter F and small letter E. Fe when exposed to moisture, this atmosphere oxygen is present, also water vapor is also present. So what happens when iron nail is exposed to moisture? It will react with moisture, and as a result, this brown colored substance will be formed over the iron nail. So this is called rust. And if you take some small amount of rust, so if you can remove this by using a sandpaper, and if you collect it in a small dish and uh, add little small amount of water. So and you may have already studied about red litmus paper. For what purpose we use litmus paper? Can you say? Yeah, good. So we are using litmus paper, red litmus or blue litmus paper. So we are using it for what? Checking the nature of the materials. Okay, whether it is acidic or basic. So in order to check the nature of the oxide that is formed, the metal oxide, that is ferrosulfuric oxide, so Fe2O3.XH2O. So this particular oxide that is formed as rust, this is known as rust. So if you take some amount of rust and you remove it onto a small dish, and if you mix it with some amount of water, and if you bring a red litmus paper close to the and keep in touch with the uh, rust. So after some time we can observe that the color of the red litmus is changing to blue color, as you can notice here. So what does it mean? It means that uh, the given substance, that is rust, that is blue, that is changing red litmus to blue. So that means the given substance is basic in nature. So you may all know that if red litmus is changing to blue color, if red litmus changes its color to blue color, that means the given substance is basic in nature. So what happens if you take a blue litmus paper? Will the color change? Yes. No. It will not change its color. So here we can see instead of red litmus, if you have taken blue litmus paper, the color will remain as it is. So that means given the nature of the iron oxide or the nature of the metallic oxide that is formed as a result of this chemical reaction, so that are associated with every chemical change. So the reaction with oxygen, especially this particular metal, when it react with oxygen and also the water vapor is present in the atmosphere. So what is happening? Metallic oxide is formed, and that oxide will be basic in nature. Bases, some examples. Can you say some examples of bases? Yeah, sodium hydroxide, potassium hydroxide, calcium hydroxide, etc. These are examples of bases. So metallic oxides also behave basic in nature. So that's why they turn red litmus to blue color. Similarly, you can take another example, say magnesium. So if you burn magnesium ribbon, so it will catch fire. If you clean the surface of magnesium layer, and if it is exposed to heat, if you heat it, what will happen after some time? It will catch fire with a dazzling white flame. So it will, during burning. Similarly, if you take an example, if you burn a piece of paper, what is happening? The carbon which is present in the paper, that is reacting with oxygen present in the atmosphere. You already know that oxygen is a supporter of combustion. So oxygen is essential for burning purpose. So magnesium, when it is heated, a small piece of magnesium if you take and if you heat it in the presence of oxygen, so what will be formed as a result? Magnesium oxide will be formed. This magnesium oxide is also basic in nature, we can say. And similarly, if you test the same magnesium oxide, take a little amount of magnesium oxide, uh, white color ash that is formed as a result of this reaction. You take some amount of that and if you keep in a watch glass and mix it with some water, and if you bring a red litmus paper and keep in contact with this particular solution, after some time you will see that the color is changing to blue color. So which means that magnesium oxide is also what, basic in nature. So here you can see. Next, one more equation. Suppose if you observe copper vessels, you might have seen copper vessels that are at your home. So if you keep it in a corner of your room for a long period of time, say 1 year, 2 year, like that, after 1 or 2 year, what will happen? You will see on the outer surface of this copper vessels, you will see a greenish color coating. So the previously we have seen, we can see one brownish coating over this iron nail, is it? So similarly, you can see what, a green color coating over articles made up of copper. So also you can see some trophies, if certain disc or trophies, if it is kept very long time in the shelf or somewhere. So after all very long time, what happens? The chemical nature of the substance is getting changed to another substance. So similarly, so we can see what is happening here. Copper vessels, when it is exposed to moist air, moisture present in the air, that is water, as well as carbon dioxide is also there in the atmosphere, oxygen is present in the atmosphere, water vapor that is also present in the atmosphere. So when metal copper, when it is exposed to these all present in the moist air, so what will happen as a result? Copper hydroxide, may you be familiar with copper hydroxide, which is a base. uh, we already studied about in class 7 what is base and uh, what is acid. Then plus copper carbonate. So what is formed as a result of this exposure of this particular metal copper with the moist air present in the atmosphere? What will happen? They will get turned to a new substance, a greenish color substance that is known as a basic copper carbonate. Basic copper carbonate. Its chemical formula is written over here. So you'll study what is chemical formula and all, how to balance these equations and all in higher class 9 and 10. So today in this lesson we have looked at only the chemical properties. Now, chemical properties of metals, especially metals. So what will happen when a metal especially reacts with oxygen, or the reaction of metals with oxygen, that we are just completed in this module. So we can go through it once again, you can see. So if anyone has got any doubt, you can just go back and watch this video again. So this particular topic, this is very important. This same topic you will again study in 10th class. So remember these all things very well and watch it clearly once again. Chemical change is associated with a chemical reaction. And similarly, you can see iron nail when it is exposed to, when you purchase iron nail, newly from shop, so it will have a silvery shining appearance. So if you keep it for a long time, what will happen? It will turn to rust, a brownish color substance. You can see over your gate also. So, so here what is happening? Iron nail is reacting with oxygen as well as air present in the atmosphere. So metals are generally highly reactive. So that's why they tend to react or interact. So in chemical properties, what we are studying, the interaction between different matter with different substances, especially metals. Metals are more reactive. Non-metals are also more reactive. There are some metals that are highly reactive and some are less reactive, that we will see in the coming part of the lesson. So certain metals they are highly reactive, especially if you take the example of sodium. Sodium metal, if you keep it in the water, if it takes very small amount of sodium, if you put it in water, it will catch fire. Even though if it is exposed, it will catch fire. That much highly reactive is that metal. So it will react to form sodium oxide and corresponding hydroxide. So that is also basic in nature. That is an example of a base, sodium hydroxide. Okay. Here you can see what is happening. Chemical change. For so one substance is getting changed into another substance. These are the initial substance that are known as reactants. Okay, similarly here also you can see these are magnesium and oxygen. These are the reactants or the substances that are taking part in the reaction. Okay. So after the arrow mark on the right hand side, what I have written is the products. So these two are two different substances. Reactants, they have got their own properties. You can see iron nail, it has got its own properties. Oxygen is a non-metal, it has got its own property. So metal and non-metal is now reacting, and as a result they are combining so as to give a different product or a different chemical substance. So the such changes, about such changes we are studying, discussing in chemical properties of matter, especially when we discuss here about metals. Similarly, as I told you, carbon, which is a non-metal, the sulfur, which is also a non-metal, phosphorus. So these all reacts with oxygen so as to form uh, corresponding oxides. But non-metallic oxides will be acidic in nature. Non-metallic oxides will be acidic in nature. Say if you take carbon dioxide gas, sulfur dioxide gas, nitrogen dioxide, these all gases, if you collect the fumes of these gases and mix it with water, and if you test with blue litmus paper, it will change its color to red color, which indicates that non-metallic oxides are acidic in nature and metallic oxides are basic in nature. So this is what we discussed in this particular session. Okay, those who couldn't understand, just revise the video and watch it again. Okay, so here what is happening? Iron nail reacting with oxygen and water vapor present in the atmosphere, so as to produce a compound called rust. So rust is chemically different from iron nail, oxygen and water. So the chemical identity of a substance is getting changed. So such properties are known as chemical properties. Okay. If you test the nature of this particular rust, that is using a litmus paper, so it will change its color to blue, which indicates that the given substance is basic in nature. And similarly, magnesium. Example, magnesium if it is burned, it will produce magnesium oxide. Sodium if it is burned, sodium oxide. Potassium if it burned, potassium oxide. So similarly, aluminium. Aluminium if you expose aluminium metal or to the atmosphere, it will react to form aluminium oxide. It will form a coating over aluminium oxide, that is known as aluminium oxide. So metallic oxide, all these oxides are generally metallic oxides are generally basic in nature. Then similarly you can see another example, common example, copper. Copper metal, when it is exposed to moist air, means water vapor, carbon dioxide, oxygen. These are all present in the atmosphere, air. So these all, when they combine or react so as to form basic copper carbonate, the product is appearing in green color as a green color coating over copper metals. So this is copper hydroxide plus It's a combination, combined product, combination of these two, that is the appearing as green color. So copper hydroxide plus copper carbonate, which is known as basic copper carbonate, which is also basic in nature. So I hope you understood this particular part. See, here we discussed about the reaction of metals with oxygen. So I hope you understood. Read the chapter well. Read this particular part again and again. And if you have got any doubts related to this particular topic, you can ask me through WhatsApp. I will be helping you. I'm happy to help you. Okay. If you have got any doubt, uh, ask me the doubts. Okay. If you need any clarification, I will give you. Similarly, go through this video one or two or three times and fix these things into your mind, and this will be useful for your higher classes. This particular activity is also explained. If you take a small amount of sulfur powder, and if you burn it, so what will happen? Sulfur, while you burn sulfur, it will react with oxygen so as to form sulfur dioxide gas. See, sulfur dioxide gas, and if you collect this sulfur dioxide gas and if you mix it with the water, what will happen? It will lead to the formation of sulfurous H2SO3, that is sulfurous acid, which is acidic in nature. So if you take this particular solution that is a mixture of what, sulfur dioxide gas as well as water, when you mix these particular two, what will happen? It will lead to the formation of sulfurous acid H2SO3. So that is acidic in nature. How can we test the nature of this particular product? If you bring a blue litmus paper near to this particular solution, what will happen? The blue color litmus will change to which color? Red color. So it will change to red color, so that we can understand the product so formed is what, acidic in nature. So this is a non-metal. Sulfur is a non-metal. As you can see, sulfur is a non-metal. So when it combines with oxygen, so as to form sulfur dioxide. So sulfur dioxide is a what? Non-metallic oxide. Sulfur dioxide is a non-metallic oxide. So non-metallic oxides, when you mix it with the water, that will lead to the formation of what? The solution that is of acidic in nature. So you can test the nature of non-metallic oxides by mixing it with water and making a solution, so that we can test whether it is acidic or basic by using what? Blue litmus paper. Earlier we used red litmus paper to check the nature of the metallic oxide. Now for checking the nature of non-metallic oxide, first we are using blue litmus paper. So when you dip this blue litmus paper in this particular solution, what will happen? It will change to red. So which indicates that non-metallic oxides are acidic in nature. And similarly, you can see if you bring red litmus paper and in contact with this particular substance, what will happen? So the red litmus will remain the same. Its color will not change. So which indicates that what, the substance of formed is the its nature is acidic. So non-metallic oxide. So we can come to that particular conclusion that metallic oxides are generally basic in nature. So but non-metallic oxides are acidic in nature. Generally, non-metallic oxides are acidic in nature, and metallic oxides are generally basic in nature. So these are the two properties, two chemical properties we need to discuss about in this chapter. Say reaction of metals and non-metals with oxygen. Okay, so this is nicely explained in your textbook. Just you read, go through it, and if you got any doubt, you can ask me. Okay, I hope you understood. So similarly is the case of carbon. Okay, so when it reacts with oxygen, you burn a piece of wood. Carbon combines with oxygen so as to produce carbon dioxide. You mix carbon dioxide with water, it will form H2CO3 as carbonic acid. So that will be acidic in nature. So non-metallic oxides are acidic. Metallic oxides are generally basic in nature. Okay, thank you.